All right, we are starting chapter 12 today, covering sections 12.1 and 12.2, getting into surface area of some prisms. So one of the things that first needs to be addressed is the difference between lateral and surface area, because you're going to see it asking for both or sometimes one or the other. So lateral surface area is just our lateral sides. So all of our edges and faces, that's the lateral surface area. So remember, our bases are kind of like the flat sides if you think about it that way. So in a triangular prism, our bases would be the triangles. In a rectangular prism, it would be the rectangles, or in any other kind of prism, whatever shape is making up the name of that prism is going to be the base. So our lateral surface area is just the lateral edges, so the sides that are not the base. And then the total surface area is going to be the lateral area plus the area of the bases. So the entire surface area. Okay, and then just one more definition. A right prism is where all of the lateral edges are perpendicular to the base. So that means that all of our lateral edges are rectangles. So let's do, we just got two practice problems for 12.1. And the first one is to find the lateral and then total surface area of the right triangular prism shown. And because it's a right one, that means that our lateral sides are perpendicular to the bases, which means that they form rectangles. Now, one thing to note about this one is that not all of the rectangles are the same size. So if we're first finding the lateral surface area, so we've got three rectangles here that we need to find the areas of. And they're not all identical. If you'll look at how this is labeled, starting with this top front side, I have a 20 by 15 rectangle for this front one. So that area of a rectangle is going to be 20 times 15. For my bottom rectangle, I have 14 by 20. So that one's also going to be 20 along here. So 14 by 20 is the length of this bottom rectangle. Okay. And then our last rectangle that's kind of on this back side is 13 by 20 because we're labeled that this side is 13. So 20 by 13. So that's the area for each of those rectangles, and the sum of them is going to be our lateral surface area, and that's going to be 840. So then to find the total surface area, I need to find the area of my bases plus the lateral surface area. And since we've already solved for the lateral surface area, I just need to find the area of the bases. So my base here is these two triangles, and they are identical. And remember, the area of a triangle is 1/2 base, which is 14, times height, which is 12 for that triangle. And I have two of them. So I'm going to multiply that by 2 and add my 840 from my lateral surface area. And what that's going to get me, 1/2 times 14 times 12 times 2. So that makes my 1/2 and my 2 cancel to 1. 14 times 12 is 168. So plus the 140, or I'm sorry, the 840, that gives us 1008. So here's my lateral surface area, and here's my total surface area. Moving on, we are now finding the lateral and total surface area of this hexagonal prism. So that means that my bases are hexagons, and that means that I am going to have 6 lateral sides because I have 6 sides in a hexagon. So to first find the lateral surface area, remember that's going to be all of these little rectangles right here, and they're all going to be 6 by 10 rectangles, and I have 6 of them. So 6 by 10 rectangles, and I have 6 of them. So that's going to be my lateral surface area. And so 60 times 6 is 360. So there's my lateral surface area. Now I need to find the total surface area, and in order to do that, I need to find the area of my 2 bases. And my 2 bases are regular hexagons. Now, if you'll remember back to chapter 11, the area for a regular a regular polygon is 1/2 AP, where A is the apothem and P is the perimeter. So remember, the apothem, sorry, I messed that up. Started drawing an octagon on accident. Here's my hexagon. The apothem is that perpendicular distance from the edge to the center. So that's our apothem. And so in order to find the area, we need to solve for the apothem. So what I have here is a regular hexagon. So I can draw a triangle on either side. And this actually can make 6 triangles. 1, 2, 3, 4, 5, 6. So I'm looking at these triangles here. So I've drawn my apothem, and that one kind of splits this in half. Okay, and I realized that this was a little hard to see, so let's look at this a little bit larger. So here's my hexagon, and I've split it into 6 identical triangles. So because this whole thing is 360 degrees, if I split this into 6 equal parts, that would mean that each of these angles here is 60 degrees. So if I draw my apothem, which is perpendicular, it's going to bisect that 60-degree angle, and I'm going to end up with 2 triangles that have 30-degree angles at the top. So if I just focus on one of them, this becomes a 30, 60, 90 right triangle, which is one of our special right triangles. And remember, if this whole length was 6, my apothem split that in half, so that means each side is a 3. And if I want to find this, now the height of this triangle, my apothem, I'm going to use what I know about special right triangles. So this is the side opposite the 30, is 3. So that means the side opposite the 60 is going to be 3 times the square root of 3. So that is my apothem for this hexagon, my hexagonal base. So my apothem is 3 square root 3. And now my perimeter, if each side is 6, my perimeter is going to be 6 times 6, which is 36. So finding the area, I'm going to have 1/2 times my apothem times my perimeter. And I have 2 of these identical bases plus my lateral surface area. Okay, and again, my 1/2 and my 2 reduces to 1. And we're going to leave this in radical form. So I have 3 times 36. Remember, multiply what's on the outside. And that's going to be 108 square root of 3 plus 360. So here's my lateral surface area, and here is my total surface area. And that is it for section 12.1. We are now going to switch to 12.2. So 12.1 was covering surface area of prisms. Now 12.2 is talking about surface area of pyramids. So we have different types of pyramids. One would be with a triangular base, so that would be a triangular pyramid. Or we have a rectangular pyramid where our base is a rectangle. Or we could even have pentagonal, hexagonal, any kind of other pyramid. Whatever its name is in the front, that's going to be the shape of your base. And so just like our prisms, we can find the lateral and total surface area. So remember, the lateral is going to be the sides that are not the base, and the total is going to include the base. So the thing about pyramids we have to remember is that we have whatever shape of our base, and then all of the lateral sides come together. They're all triangles, and they come together at the top. So when we had regular pyramids, that means that all of our lateral faces are congruent isosceles triangles. That means that every single lateral face is a congruent isosceles triangle. And then just one more quick review about some vocabulary. Our slant height goes through the middle of one of our faces. Our altitude is perpendicular from the point at the top to the base. And our lateral edge is where 2 of our lateral edges meet, okay? Where our lateral faces meet, excuse me. So again, we just have 2 quick problems we're going to work through. The first one is asking us to find the lateral and total surface area of this regular pyramid shown. So because it's regular, that means that all 4 of our lateral faces are going to be congruent. So first, to find the lateral surface area, that's going to be for these 4 lateral faces, and they're all triangles. And remember, the area of a triangle is 1/2 base times height. So here I know my base is 12, but I need to find the height. So I'm going to draw in my slant height, and that's going to be perpendicular to my edge, and it's going to bisect it, so that's going to turn these both into 6. And I know if that side is 10, this is actually a 3, 4, 5 right triangle, so my height is going to be 8 because each one was multiplied by a factor of 2. So 1/2 base times height is the area for all 4 of these lateral faces. So for my lateral surface area, 1/2 12 times 8 is 48, and there's 4 of them. It's going to be 192. Then to find the total surface area, I need to find the area of my base. And this is actually a square. It's a 12 by 12 or a 12 by 12 rectangle. So the base area is 12 times 12. And so for the total surface area, I'm going to add my lateral surface area. So 144 plus 192 gives me 288. So here's my lateral surface area and my total surface area. And last but not least, again, we have a regular pyramid with a slant height of 8. Remember, the slant height is this distance right here, so I'm going to label that. That's 8. And the area of its square base is 25. So if its area of the square base is 25, that would mean that each of my sides is 5 long. And we want to find its total area. So that means I need to find the surface area of my lateral faces plus the surface area of the bottom. And we're told already that the surface area of the base is 25. So I just need to find the area of each lateral face. So if each side is 5, there's my base for my triangle. So 1/2 base times height. And again, I have 4 of these plus the area of the base. So 25. So 1/2 times 5 times 8 gives me 20. So I end up with 80 plus 25. So 105 is my total surface area for this pyramid. And that wraps up sections 12.1 and 12.2.